All right, so the good news is today we're not really looking at something new. Basically, you've literally learned all the skills you need so far. So as long as you're good with the homework, which I only got from 3 people, or now I think 5, that homework is key because we're just going to keep using those skills for the rest of this unit and show you how they can be applied to certain things in the real world. But we have to go one step further with it, which is what happens if we have more than one inequality? So in the first one I've got here, you can see there's no longer just one inequality. There's actually 2 inequalities to worry about here. So there's 2 of them. Now, the process is going to be the same, but this time it's kind of like your citizenship test, just got more difficult. Now you don't have to pass just one test, you have to pass 2. So it only counts if you can fulfill both requirements. So let's take a look here. I'm going to do the first one to give you an idea how it works, and then I'll let you guys work on them. But to see if 0, 0 is a possible solution, it has to work for both. So that means if I plug them in, the first one will be 0 less than 2 times 0 minus 3. Is 0 less than negative 3? No, it's not. 0 is not less than negative 3. So immediately I can say that is not a possible solution. The only way it works is if it works for both. So as soon as you hit one that doesn't work, you're done. You know it's not a possible solution. So I'd like you to take a look at those other 3 and tell me which ones are solutions, which ones are not. Okay, so 3, 9. Did anybody figure out if that worked or not? Can I just see, what do you say? No, it doesn't. How come? Yeah, it doesn't work on the first one. So 9 less than 2 times 3 minus 3 is 9 less than 3. That does not work. So this is not one of the solutions. Okay. And how about, did anybody get as far as 5, negative 4? Yeah, does 5, negative 4 work? Oh, there's some debate here, yes and no? Okay, well then let's just double check. If I have negative 4, so right, I'm putting in for x and y. Negative 4 is less than 2 times 5 minus 3. So negative 4 is less than 10 minus 3. Is negative 4 less than 7? So it works in the first equation, but that's not good enough. That's a start. So we got to try again now with the second equation. So 3 times 5 minus negative 4, is that greater than 12? So 15 plus 4, is that greater than 12? Yep, it sure is. It works on both. That is a possible solution. Did we get the last one? Last one doesn't work? Okay, how come the last one doesn't work? It works in the first, but not the second. Okay, so let's see. Negative 7 is less than 2 times negative 1 minus 3. So negative 7 is less than negative 5. That is true, so it works there. And if we try it again, then I'm going to have 3 times, negative 1 minus negative 7. Is that greater than 12? Sorry, that should, did I do that right? Yeah, okay, so negative 3 plus 7, is that greater than 12? No, that's going to be 4 greater than 12. Doesn't work, doesn't work. So we're not going to need to do this. I'll show you how we can do this without having to check every single point, but that's the scenario we're working on today. You have more than one constraint to fulfill. Okay. So here, let me show you what it looks like now when you draw a picture. I'll walk you through this first one. We're going to proceed exactly as we normally do. So the first thing I do when I look at this system of equations is I plot the lines. So the first line is at negative 3, and it is 1 up, 3 over. Okay, and it is a solid line because it's got the equal sign in it. And just like I normally do, I'm going to test a point to see which side of the line it goes on. Okay. So I might as well pick 0, 0. That's my favorite, and it's not on the border, so I'm allowed to use it. So is 0 less than or equal to 1/3 0 minus 3? Is 0 less than or equal to -3? Is that true? No, 0 is actually bigger than -3, right? It's better to have no money in your pocket than to owe $3. So we've got this side of the line. And this is the only difference I'm going to ask you to do this time. Instead of shading the whole thing, I just want you to make a little tick marks along the edge instead of the full shading of your graph. The reason why is we're not finished yet. So I just want to mark it so I know for myself that this is part of my answer. Okay, and now we do the same thing with the other line, where we go, let's graph this line here. I start at 1, and it's negative, so it's going to drop by 1 over by 1. So something like that. The line is a solid line. So like that. And just like before, I'm going to test a point and see which side of the line I go on. So my favorite ones available is 0 greater than or equal to 0 plus 1 is 0 greater than or equal to 1. What do you think? No, it's not. So if it's not on this side, that one fails. It's going to be the other side. So we're just going to use little tick marks here. So remember, it's not good enough now to pass one test. You have to test both. So now you can think of this as a map with, instead of having 2 countries, you have 1, 2, 3, 4 countries. So which country do you pass the citizenship test in both?
4.
Number 4. So that's our answer. We're going to shade in here. Okay, so that's what it looks like today when we add another inequality to it, is it only works where everybody agrees. So please try the second one with your neighbor. I will ask somebody to come here and show us what you did. Okay, so for the first graph, we're going to move down to -2. And then it's going to be over 3 and up 4. Then on the second graph, we start at 1. And we go over 3, up 1. So I'll draw those lines. One of them is dashed. This one here, this purple one, is a dashed line. And then the other is a solid line. Oops, that was bad. Let me try again. Close enough. All right, so there's what my lines look like. The problem now I have is I have to figure out which parts to shade. So let's take a look at this one first, which is in purple. So if I put in 0, is that less than -2? No, it's not, so I'm going to go on the other side. All right, let's go to number 2 here. And is 0 greater than or equal to 1? No, so I have to go to the other side of the green line. So that would be what my rough work looks like. The answer that I have to shade in is this part in here. Okay, hands up. Who got it? Excellent. Okay, good news. So the only thing I want to practice before we move on from this is that some of that notation changes. So for example, in this first one I want you to try, you have to do rearranging. And in the second one, it's all that really weird math garbledy-goop. So let's start here. Just do your, hey, it is a technical term. Look it up. I'm sure it's in the Urban Dictionary somewhere. Garbledy-goop? I don't know. Anyway. Ask Miss O'Malley, because they maybe English teachers know how to spell stuff, right? So anyways, give this one a try over here. This system of equations, you're going to need to rearrange before you plot your answer. Okay, let's see how we did on the first one. If I do some rearranging, I'm going to get a line for the first one. That is y equals negative 5x plus 2. So that'll be here. And I'll drop down 5 over 1. So it's a pretty steep line, and it is a dashed line. So there's the first one, and I'll choose 0, 0. So is 0 less than 2?
Oh, yes.
Yeah, 0 is less than 2. That's okay. It's still early. So this is the side of that line that I go on. And then for the second equation here, I'm going to get the line y equals negative x minus 2. So let's do it in green. It'll be minus 2, and I drop 1 over 1. So the line's going to look kind of like that. And again, I'm going to end up doing a dashed line through these points. So it should look about like this. So I'll test my favorite point, 0, 0. Is 0 less than negative 2?
No.
Nope, not in this case. So I'm not on that side where 0, 0 is. I'm on the other side here. I'm on this side below the line. So if I look at this and I ask you, this is 1, 2, 3, 4. Where is it that everyone agrees that we belong? Let me see then. Okay, hands up if you think it's, let's go with number 1. Okay, if you think it's number 2. You think it's number 3. Number 4. And you have no idea. Okay, for the most of us that did pick it, it is correct that number 1 is where you want to be. So we're going to shade that whole thing in. So the last one is with that crazy notation. And I'm just going to remind you of what it means to us. Basically what we're going to do here is we're just going to say we don't need to know that much of it. And we don't need that either. We just need to look at those constraints so that our picture will show those constraints. Okay, so the ones we're working with are 2x minus y is less than negative 3. 4x plus y is greater than or equal to negative 3. Just like we did in the last questions. But what else is an additional constraint here? Yeah, we're dealing with whole numbers. So x must be a part of whole numbers, y must be a part of whole numbers. Can someone refresh my memory? What does that mean if you're a whole number? 0 is in there, yeah, what else? 1, 2, yeah. The only thing we don't include are negatives, right? Otherwise, we'd be talking about integers. So in this case, it's going to be 0 and larger whole numbers. So you guys take a minute or two to put this down, and remember, it is only the whole numbers you are going to highlight in your solution. I'm going to show you this first line with 2 different approaches, okay? Approach number 1, this is entirely correct. However, it is not my recommendation, and you'll see why once we look at approach number 2. Approach number 1 is to say 2x minus y is less than negative 3. And we're going to continue to work with the inequality and simplify that inequality. So you would go negative y is less than negative 2x minus 3. And now I have to divide everybody by negative 1. But what happens to the inequality? It ends up flipping. So that's something that you guys would have done a long time ago. Some of you might have forgotten about it. But that's one reason I don't recommend this, is then you have to keep track of your inequality signs. Okay, we only need this one inequality here to test the point that shades the region. There's no need to go all the way to this one, even though it's simpler. You don't have to do that. So approach number 2, so let's say this is approach number 1. Approach number 2 is just to say we're going to use an equal sign Because the only reason I want to rearrange it is so I can graph a line. And a line, I only need an equal sign. So that's what I'm going to work with here. It's going to be negative y is negative 2x minus 3. Y equals 2x plus 3. So you'll notice that I end up with the same equation. The problem is, though, that could be different, which would give you the wrong answer. So in this second approach, you're not worried about whether the sign has been messed up or not. You just graph the line and then test the point. So let me show you. I go 3 high, and then it's a slope of 2, and it's a dashed line. So it's going to look something like this. And then I have to test a point. So you only need one inequality to do that. I've done it correctly up here. I could test it on this one. I could test it on this one. I could test it on this one. They're all the same. We've just rearranged the same inequality. So that's why this one is nice, because I just go right back to the same inequality here and test the point in that one. So it'll be, is 0 less than negative 3? Is that true? No, it's not. So I'm going to shade this side of the line here. So that's what you should get for the first inequality. And again, I really recommend you focus on the green writing there. That way there's just less chance of you making a mistake with your inequalities. Draw a line, test a point. That way you're not worried about flipping things around. If you like the red way better, the one circled number 1, go for it. But my suggestion is that you try with number 2. All right, so let's take a look at the last graph there, which is 4x plus y equals negative 3. So are there some questions that people want to ask about before we go on to this next graph? Okay, questions then? I see some heads nodding, but I need to hear the questions. I can't just reach into your brain and pull them out. Okay, I'll pause it then so you don't have to be on YouTube. So continuing with this, we were at negative 3 and the slope was negative 4. So it's going to go like this. And it is a solid line. So if I test my favorite point at 0, 0, it's going to say, is 0 greater than or equal to negative 3? And in this case, it's true. So 0 is greater. It's going to be on that side where 0, 0 is. So I can see if I was to think about these like countries, and this is a map, it is region number 4 that I'm interested in. However, it is not everybody in region number 4. It is only the whole numbers. So my solution is going to look like this. Just shade in the numbers like this to show that it's only the whole number solutions. And I believe we agreed that I would understand as long as you had about 6 points there to draw. So you don't have to draw them all, but as long as you have 6 or more, I'll know what you mean, and that way it'll be enough that I agree with you. Okay? The other part of it, though, if you shortcut and you only draw your 6 points, you have to show me which region you mean. Otherwise, I don't know if you meant that you went to this side as well. So you have to just go like this and shade in that area so I know you mean in here, and draw your dots on that area so I know you mean only the whole numbers in that area. Okay, so that one was a tough one, I agree, but that's why that was our last one. So is there any questions before we move on, or I can pause the video if you don't want to be on YouTube? You guys are so shy.
Make a joke.
Make a joke? I'm a math teacher. I don't do jokes.
Make a math joke. That was a funny joke.
Let's see here. I'm thinking of some. Oh, go ahead.
What did the mermaid wear to math class?
What did the mermaid wear to math class?
An algebra.
An algebra. Like an algebra?
Yeah.
Okay, I got it.
Oh my goodness. Just don't. Why?
What did the acorn say when it got older?
Acorn.
Geometry. 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 I know. I can't think of. There's some really good lame ones out there, but that's about as. See, this is why I don't do jokes on YouTube, right? I'm gonna get some thumbs down now because of you guys. All right. Anyway.
It'll be me. Sorry.
So here, what I want us to practice in this question is I want us to practice modeling now. So it's not as bad as you think. What I want you to try and do is I want you to follow a set of steps with me, okay? First thing we want to do is identify your variables. We're going to keep building on this structure, so these steps are going to be the same with each lesson that we do, but we'll add an extra step as we go. So first we're going to identify our variables. Then we are going to write out our constraints. And then we'll do a model with a graph. So I want you to read through this problem, and all I want you to do for now, and then we'll pause for more time. All I want you to do is write out your variables, like let J equal lame jokes, right? Whatever it is that you come up with. So if you weren't completely sure of what the variables are, does anybody want to share? Yeah, A for aluminum and F for fiberglass will work for us, so let's write that down. So A is aluminum boats. And then F is fiberglass boats. Okay, so now when we write out the constraints in part 2, we have to use the letters A and F to describe them. And our constraints are going to use less than or equal, greater than or equal. The way this problem was written for you, there is one constraint here and another one here. So that's all I'd like you to do for now is try and write out a single constraint for part number 1. Read that and tell me what you think it would mean in math. Okay, I know of at least one person who has the first constraint. Can anybody take a stab at what the first one I circled up there is? Yeah, so we definitely know that in constraint number 1, something has to be less than or equal to 20. What has to be less than or equal to 20? A plus F, right. Aluminum plus fiberglass boats has to be less than or equal to 20. Nice, okay. The second one is a little tougher. So what I'm going to suggest that we do here is talk it out together. Now it says the demand for fiberglass boats is greater than aluminum, and they make at least 5 more fiberglass than aluminum. Okay? So first of all, what we know is we're going to make, if I have fiberglass, it has to be greater than or equal to aluminum boats, right? There's more demand. How much greater are fiberglass boats than aluminum boats? 5 more. So if you're not sure about how to set up your inequality, if you tested something, let's say I made 1 aluminum boat that day, then fiberglass would have to be greater than or equal to 6. So 1 to 6, that meets the constraints, right? I could also be greater than, so I could be 7, 8, 9. This models the situation properly. So if you're not sure, you can always test it by putting some numbers into your inequalities. So those are the 2 constraints, and we're going to use them now to model it with a graph to show you what possibilities we have. There is, however, one tiny constraint we haven't talked about. It has something to do with, yeah, there, so you're already onto it. Don't need to show it again. They have to be whole numbers. So they have to be a part of the whole numbers because we're not going to build 1.1 boats. We're going to build 1 boat or 2 boats.
It's not very fun.
Ouch. All right, so our last job then is to take what we just had and make up a graph. So I'm going to let you guys get started on your own graph. However, I am going to make one suggestion to you. We're trying to think of this as like X's and Y's, but we have A's and F's. So how do we go from A and F to X and Y? One of them down here looks a lot like one we could start with right away. If this was the inequalities we've already worked on, yeah, then F would be Y and A would be X. So that means I'm going to put my F here and my A there. for when I graph the solutions. Okay, so I'm going to do my scale in fives. So if I do my scale in fives, F I need to get up as high as 20. So it'll look like this. And it says, if I look at, let me get rid of some of these things here just to tidy up. If I look at the first one, I have F equals A plus 5. So I'm going to march up by 5. And then that has a slope of 1 here. So with a slope of 1, I would go over 5, up 5. And the reason I'm using 5s is that's the scale on my graph. You can go over 1, up 1 if that's your scale. That's fine too. The other equation is A plus F would be equal to 20. So F equals negative A plus 20. So I'm going to start at 20. And I'm going to go over 1, down 1. So I'm going to, the easy point for me on this graph, and again, you can pick any point you like, is to go down 20 and over 20. So that way I can get my graphs going very easily. That's not very good. Let me try that again. Yeah, that's a tough line to do. One more time. Good recovery. Okay, so this is roughly what my two lines are going to look like. And now we can test a point, but let's talk about some common sense here to see if we can get the whole thing done. If I'm on the purple line, and the purple line belongs to constraint number 1, are we going to be below that line or above that line? We are going to be below. How come below? We can't do more than 20, right? The factory would be like working overtime. So it's going to be this side of the line that I'm using. And then if I was to work on the other side, which is this constraint number 2, which side of that line is it going to be? Yeah, the top, because the fiberglass boats have to be more than the aluminum boats, so it's going to have to be like this. So that means that my solution is in here, but it's only the whole numbered ones, so I'm going to do some dots in there just to show you that it's only these ones that I'm interested in. Okay? Any one of the whole numbers that go in there, that also includes all the ones on the axes too, but all the whole numbered values. Okay? So what that shows is every possible combination of aluminum and fiberglass boats that they could do. Now the reason that we're getting towards this kind of a thing is, as the owner of that boat manufacturing company, you might want to ask yourself, well, if I make $1,000 on every aluminum boat and $1,200 on every fiberglass boat, if that's all possible combinations of boats I can build in a day, which ones should I shoot for? Because some of them are going to produce more profit, and some of them are going to produce less. Some of them might even lose you money. But out of all those possibilities, we could go there by hand and check every single one until we figured out which one it was, or we could come up with a better technique, which is coming up later. So all I want us to do here is go through the same process, but I want you to try this one from top to bottom with your neighbor, okay? So start with variables. Once you find the variables, come up with a constraints. Again, there's 2 of them, and they are both marked. And then finally, draw your picture. Now, just so you know, are there any sailors here?
I have a boat.
Is it a sailboat? Well, if you don't know sailing that well, you're not alone. This is a mainsail, and this is a jib. This is the mainsail, and this is the jib. So when you read the problem, that's what they're talking about, is how much of the mainsail they're going to put out, or how much of that sail in the front. So there are 2 sails on the boat. Okay, so let's take a look at where we're at here. What are the 2 variables that you picked for this?
M and J.
M and J, as in Michael Jackson. That came up in the last class too, but unfortunately it's not as cool as that. We're talking about the mainsail, and we're talking about the jib. Now, how are we going to do the constraints? What constraints can you tell me from this?
Equal to or less than 80.
So what is less than or equal to 80?
That's what I asked you.
The mainsail is, yeah. Okay, that's one of our constraints done. And it says Jim also wants more mainsail than jib. So how can we write that?
So M more than or equal to J.
More than or equal to?
More than.
More than, okay, so greater than. So you could be, in this case, they're both really easy to graph. You could pick X and Y for either. But I'm going to say that since everybody likes being on the left for Y, I'm just going to pick it because it's already there, okay? So that means when I go to graph this, this is my mainsail, this is the jib. And the first constraint, how do you write out something like M equals 80? How would you do that?
You go over across the line.
Yeah.
Straight line.
So let me, 1, 2, 3.
You'll be going horizontal.
1, 2, 3, 4, 5, 6, 7, 8, 9. Good enough. All I need is 80. So that's 80 there. So I start at 80, and it is a solid line because it can be equal to 80. And again, you could test a point, or you could just ask yourself, which side am I supposed to be on? And it's the bottom. You got to be underneath that 80 line. Otherwise, your mainsail is out more than 80%. Okay, the second line is M equals J, which looks like this. We start there, and it's going to have the same over 1, up 1, or whatever your scale is. So mine, I can pick a point anywhere like over 10, up 10, over 20, up 20. So it's going to look like this. It's a dashed line.
Why do you take from there?
Why did I do it at 0, 0?
Oh, never mind.
There's a 0 there. And again, ask yourself, what side of this line should I be on if M has to be bigger than J? The top. Yeah, I've got to be more, so I'm going to be up here. So that shows me where my solution is. My solution is in this area here. Now, am I worried about whole numbers, or what do you think? No, I don't know if you've ever seen when they do that big, they're cranking on those reels when they're sailing.
Yeah.
When they crank on those reels, they're letting more sail in or out. So if you picture that rope, you can be any length you want. You can let out half, you can let out 0.47, you can let out pi even. At any number you want, you can do. So we would just shade this whole area in, and that would be our solution there.